So on the board, we've got 3 statements, and they are definitely true.
In this video, the teacher uses an activity to introduce students to the idea of proof by contradiction.
We started with 3 statements that should have been fairly obvious as being true. And then we said, rather than trying to prove this statement directly, let's try and explain why the opposite of this statement cannot possibly be true.
Can you write the opposite of each of these? And this is known as negating the statement. So if this wasn't true, how would we write that? Could you give me a statement that said something that defied that, something that made that not true?
This was quite tricky, I think, because they're not used to that negative statement, finding just one example of when it wouldn't be true, so that it therefore isn't always true. So we talked a little bit about how you made a statement the opposite of what it says, and then we tried to take the statements we'd been given and try to write down the statement that effectively said the opposite of that one.
If I said the sum of 2 even numbers is always even, and you didn't think that was true, how would you rephrase that? Or what would be the opposite of that? You would say, anybody?
The sum of 2 even numbers isn't always even.
Brilliant. That's what I said you weren't allowed to do, but you could say that. The sum of 2 even numbers is not always even.
I hope that they would think in a little bit more detail about exactly what a statement was saying. So if a statement says that if something is always going to happen given certain circumstances, then the negation of that would be that there is at least one case where it wouldn't happen.
There exist 2 positive numbers, A and B, that sum to a negative number. And we're going to prove that that cannot be true. So, the sum of 2 positive numbers is always positive.
I think they struggled a little bit. I think they couldn't quite see it at the starting point where it was heading. Once we then got to a situation where we were actually showing that those statements that they'd written down effectively created a contradiction, and they got the bigger picture, I think they felt a little bit happier with what the whole task was trying to achieve.
So what we've basically done is we've said that a statement that we actually know isn't true, we've proved doesn't hold with our original statements. It's much easier, or it's very straightforward to prove that that can't work given our original assumptions. I'm going to ask you not necessarily to do that proof, but to look at the 1, 2, 3, 4, 5, 6 statements here, and just write down what is the negation of each of those statements, and then we'll pick one of them and we'll try to prove that that negation doesn't make any sense.
What I was hoping they would get out of it is understanding this idea of a negation of a statement or the negative of a statement, which isn't something they've come across before. Because clearly if you can't have that negated statement, then it's very difficult to then, well, you haven't then got a correct statement to then pick apart and show that arrives at a contradiction. We help that come about, if you like, by using some key vocabulary, getting them to understand that the opposite of something always happening given certain circumstances is just that it is possible for it not to happen. There exists at least one case where it wouldn't happen.
Yeah. So for invisitive integers.
The way to help them with that was to think of key words, key phrases, key expressions that they could use. Things like, is this always true? Is it not true? There must exist at least one number, or there is a case where, rather than just it won't always be, or it can be, but sometimes it is, sometimes it isn't. And again, that can come out from giving specific examples.
Yeah, rational. Yeah, you just change that to rational, don't you? The last word.
Mm-hmm.
Oh?
Yeah, but if you're doing it like that, you wouldn't.
So what do you say, there exists? There exists? Oh, right, okay. Should I say it like that? There exists
A rational number and an irrational number.
So if you could just read out what you've put. And one of the things I just want you to think about is the language you use. And I've discussed with a couple of you that sometimes this use of there exists one rather than there is some or there is any. So the sum of 2 odd numbers is always even. Could someone give me the opposite of that statement?
There exist 2 odd numbers that, when added together, are odd.
Absolutely brilliant. Yeah, we just need to explain there might be a counterexample to that. So it is possible to find 2 odd numbers that when you add them together, you get an odd total. That would be perfect.
Certainly what I'd like to do next is unpick that proof by contradiction, if you like, and make sure that they absolutely understand the nuances of it. Make sure they understand that you have to word your contradictory statement correctly. You then have to do an algebraic rigorous proof going through, or rigorous set of processes going through. And then when you can see that clear contradiction at the end, you know that the original starting statement must have been true. And if that's been worded carefully enough, then therefore you've proved what you wanted to prove. As with anything that you know they're going to find tricky, just being prepared for them to give you some funny expressions at the beginning and maybe not get entirely what it is you're trying to get them to do, but also really, really praising and really, really encouraging them when they're going on the right lines and when they've got something, and really sort of bigging up, if you like, or impressing upon them just how powerful those 3 or 4, 5 lines of working can be in terms of showing that a statement has to always be true.